Our account now has 0.001 Ether assigned to it on the RinkB test network. If I select the server dropdown or the network dropdown up here and flip on over to, say, the Ropsten network, you'll notice that our balance goes down to 0. But if we go back on over to RinkB, we go back up to 0.001. I want you to recall what we just discussed 2 or 3 videos ago. We had said that every account that we make in the world of Ethereum lives in its own separate universe, like its own world, and it is completely decoupled from any of the different Ethereum networks out there. So as far as RinkB is concerned, our account has 0.001 Ether inside of it. But as far as any other account is concerned, our account has 0 Ether inside of it. All these different networks can still have ties to this one singular account that we control. I just want to make sure that point was really clear. All right, so now that we have that under control, I want to think back to the process that we just went through when we submitted the form right here and sent ourselves a little bit of money. So we're going to go through the exact order of operations that went on behind the scenes when we entered our address in here. So let's go through that flow. As we go through this flow, it's going to give us a much better idea of how some of the different details around sending money works with Ethereum. So here's the flow. Again, this is a very technical description of what happened when we submitted the address on that form. So we entered in the address and then we clicked the submit button. That web page then took the address that you entered and submitted it to a backend server. This is a Node.js server that I wrote specifically to take your address and send a tiny bit of Ether to it. To make that server, I used the Web3 library. Remember, the Web3 library is a tool that we use for developers to interact with any given Ethereum network, not just the main network and not just RinkB. We can use it to interact with any Ethereum network. It's a programmatic portal that we can use to interact with all these different nodes that exist out there. So our backend server used that Web3 library to create what is called a transaction object. Now at this point, we're going to take a quick aside and we're going to talk a little bit about what a transaction is. So quick aside, and then we're going to come back and finish off this flow. All right, so over here, here's a diagram of a transaction. You can think of a transaction as being a record that describes one account attempting to send money to another account. A transaction is created anytime two accounts exchange some amount of money. So when I just sent some money to you, I created a transaction object and then submitted it to the Ethereum network to be processed. This object has a variety of different properties assigned to it, which you'll see labeled over here to the left-hand side. We're going to walk through a couple of these different properties and talk about what their purposes are. The first property that exists on a transaction object is a number that tells us how many times the sender has sent a transaction. In this case, my server is the sender. That is the person or the entity that just sent you some amount of money. So if that account has been used, say, 1,000 times to send 1,000 different transactions, then to send you money on that 1,001st transaction, that transaction would have a nonce of 1,001. You might be a little bit curious about the term here, nonce. Like that seems awfully unrelated to what it actually means. Like why didn't they call this transaction count or something? Well, you'll see this term nonce used several times throughout the Ethereum world. Nonce is short for nonsense, or essentially something that is pointless. I don't know, nonsense, right? In this case, it's definitely not nonsense. You know, it's a very reasonable value, but that's what they decided to call it. So, hey, we're stuck with it. The next field that exists on a transaction is a to property. This is the address of the account that some amount of Ether is going to be sent to. So in the transaction that was just issued, the to field would have had an address equal to your account address. Next is the value. The value is the amount of Ether that we want to send from the sending account to the target account, essentially to your account. In this case, it was 0.001 Ether. You know, that was exactly how much money you just received right here. Now, last two properties, or I shouldn't say last two, but two of the other properties on here are gas price and start gas. and start gas is sometimes called alternatively gas limit. We're going to come back to these two terms right here later on, but for right now, if you're kind of curious about what they're about, you could read the description right here. But like I said, we'll come back to these two terms. Now, one of the more interesting pieces of the puzzle here are these last three properties. They are abbreviated as V, R, and S. So when we look at this transaction, I see like nonce to value. I don't really see anything that seems to specify where this money is coming from. In addition, I don't really see anything in here that seems to specify or provide a private key or a password or something that says, hey, you can take money out of Steven's account. Hey, what's to stop you from submitting another transaction that says, hey, go find Steven's account and take all of his Ether and submitting that transaction to the network to be processed? Well, that's where these V, R, and S properties come into play. These are extremely complex pieces of data. And I mean that in a very serious way. When I say extremely complex, I'm talking about extraordinarily complicated cryptographic stuff. Stuff that I personally don't feel comfortable even trying to begin to explain. This is some very PhD level stuff that goes on with these different properties. But as a summary, I can essentially tell you that these VRS properties are generated by the sender's private key. So the sender will take their private key, they generate these three values, and those three values can then be used to generate the account address of the person who is attempting to send the money. Now, generating the V, R, and S from the private keys or from the private key is what we refer to as a one-way process. So if you have the private key, you can generate V, R, and S. But if you have V, R, and S, you cannot kind of back calculate the private key. So the private key is used one time to generate these numbers, and the existence of these numbers and the fact that they eventually result in a address, that's how we verify that it is a legitimate transaction, because we cannot take VRS and somehow redefine the private key, and we can only use VRS to calculate one particular account address, and that is the sender's address. So that's where the level of security comes from here. Okay, so that's a very brief description of what a transaction is. Now we're going to pause right now, and when we come back, we're going to finish up the rest of this flow. So I'll see you in just a minute.